Hello guys and welcome in this new recording. This would be a short demonstration of the result that I have now for the atmosphere rendering, as you can see here already. So this took me quite a lot of time. In fact, I've been working on that for multiple weeks now, and the path was very tricky. It was really not working initially. I started with writing a lot of unit tests, testing all the computation steps that were required to produce the free textures that we need here to render the atmosphere, so that the transmittance, the irradiance, and the scattering texture. Keeping in mind also that the scattering texture is in fact a 3D texture here. And yeah, after that, when I had some, I mean, all those unit tests working properly, I was confident that I could maybe try to use this atmosphere model now to render it on my planet here. But the first results were not good at all, and I only got a completely red atmosphere display, and it was completely incorrect everywhere. So yeah, I started another loop of testing what could be wrong, and in fact at that point I switched to the original implementation and I tried to compile that, and I was then using this as a reference to get the texture data, and I was trying to compare what I had as reference data and what I was computing myself. And yes, using UBarter to do the comparison, I eventually figured out that I was not generating the scattering data properly, so I was I forgot to copy the data at some point, and that explained why I was getting only very weird display, completely red and so on. After that, I spent also some time trying to figure out how to deal with the depth retrieval for the rendering, because what we have here is actually a two-pass rendering. We have the first pass where we render only the terrain itself, so all the mountains and so on, and from that first pass we are going to also write the depth value. So here you have no depth, so depth value is 1, and when you start displaying something, your depth value are getting smaller and smaller. And you need that because then you have another pass where we do the rendering of the atmosphere itself. And for the atmosphere, we're going to cast rays for every pixel that you have on your screen. But then those rays, when they do not intersect the ground, you only need to compute the radiance that you get from the sky and the atmosphere. But when you intersect with the ground, you need to compute the um, the radiance that you get on the ray from the ground only to your point of view. So yeah, at that point you need to know what is the depth of every of those pixels, so you can perform this computation properly. And yeah, this is it basically for the moment. This is still pretty far from perfect. In fact, there's still a lot of work to do, because what we don't really see here is the depths that I'm writing are just written in a regular way, if you want. So depending on your point of view on the planet, if you're close to the ground, you need to render from very close value to not so far value, and then if you go further away, you're going to change the near and far planes. But yeah, the accuracy of the depth value that you write is very low, in fact, and you can notice that if we start moving away from the planet. So if you go up, everything's in... Oh, you start to see some weird display here in the corner, and here it goes completely crazy, and I'm pretty sure this is related to, yeah, imprecision. And here, yeah, it's completely incorrect, and that's, I believe, our imprecision in the depth value. So next step for me is going to be to change how I I am writing those depth values, and maybe to start using a logarithmic depth buffer, we'll see. But anyway, I thought that yeah, this was interesting result already. It took a lot of time and a lot of effort, but it was definitely worth it. So this is it for this time. I hope you liked this video, and if it's the case, please consider giving it a thumbs up. And in any case, I'll see you next time. Bye bye!